So if you could sum up this topic with one snappy phrase, what would it be?
Making the heart of a star to power the world. Nuclear fusion is about fusing atoms to release huge amounts of energy. We know it's physically possible because it happens in the core of the sun. We do already have nuclear reactors and we have nuclear power stations, but those are fission reactors, and that's when atoms are split to produce the energy. In fusion reactors, atoms are fused. It takes an enormous amount of energy to bring atoms together to make them fuse. And the problem is that nobody has been able to get more energy out than they've put in. But the ratio is moving the right way. Just to give you an idea of the potential for fusion energy, a glass of water like this contains enough fuel for the fusion process to meet the energy needs of one person for the whole of their life. People really want to crack fusion energy because it's clean, it doesn't produce carbon, and it produces a lot less radioactive waste than current fission nuclear reactors. There's been some great news recently, a real breakthrough at the Joint European Torus, that's the jet facility near Oxford, and it happened this February, and they produced more energy than they've ever produced in a fusion experiment, a total of 59 megajoules over the course of 5 seconds, and that smashed its own world record that dated back to 1997. And the really nice news about that is that it shows the method works. It's a proof of principle. It follows hot on the heels of what's happened in the US at the National Ignition Facility, and it produced 1.3 megajoules compared to the 59 produced at JET. China is also chasing fusion energy and recently managed to sustain a fusion reaction at 120 million degrees for 101 seconds. So after a slow burn for decades, fusion energy really seems to be going places, and you can sense that from the amount of private money sloshing around. According to the Industry Association, private companies have raised more than $2 billion of investment. There's been talk that we could have fusion energy by the 2030s, but the standing joke really in the field is that fusion energy is always 20, 30, perhaps 40 years away. I think the difference today is the amount of private enterprise, both in terms of money and effort. And we could see that change the game in the same way that commercial entrants changed the space industry. If we could get fusion energy to work, we still have the challenge of scaling it up, and that is massive. Just to power the US grid, for example, it's been estimated it would take 3,000 reactors at a cost of $1 trillion. So where do I think we're going with nuclear fusion? Well, I think globally the most important climate target for us right now is net zero, whether that's by 2050, 2040, ideally even before. And I think the key question for me about fusion is whether it can scale up quickly enough to be in the mix for our carbon-free future. And that's why I think this decade could make or break fusion energy.